Good morning, students. So today we'll study about the chapter. The topic is metals and non-metals. Let us see how they are different from each other. Okay. So the chapter is metals and non-metals. Okay. This is a topic. This is the most important chapter in class 10th. So, as boards are around the corner, so we'll study. Let us see how we able to distinguish between metals and non-metals. How we can say that what is metal and what is non-metal. Okay, so we can differentiate between them in two ways: by physical properties, okay, and by chemical properties. So we have to take these two things step by step. So first we will take physical properties. Okay. So physical properties, what they say between metals and non-metals, how they able to by which see we can distinguish between them. So let us make a table. Metals and non-metals. Okay. So lots of things are there. We'll see. First one. Metals, for example, if I say sodium, potassium, calcium, lots are there. And non-metals also, they are, sulfur, carbon. So we have lots of examples of non-metals also. But now, right now we'll discuss about their physical properties. For example, metals are solid at room temperature. Metals are solid at room temperature. Exceptions are always there. So if I say in exception, mercury. Actually, it is not solid at room temperature, it is in liquid form. Now, if I talk about non-metals, non-metals in all forms, all three states, solid, liquid, gaseous form, in three states you can find non-metals. Now, second thing is about metals are hard. Metals are hard, but we all know exceptions are always there. For example, if I say sodium and potassium, they are so soft that they can be cut by knife also. Okay. Now, about the thing is non-metals. They are soft. They are not hard. They are soft. Okay, but here also exception is there. That is carbon. Carbon has two allotropes. Two allotropes. That is diamond and graphite. Okay, so we have diamond and graphite. Now, in this, diamond is hard. So, we are discussing about the differences between metals and non-metals regarding physical properties. But likewise, what we have seen here is about the solid or the hardness or softness is there. But few exceptions are there. We can say all metals are hard, like all non-metals are soft. But we have exceptions. Like in non-metal, diamond is hard. In metals, sodium, potassium, they are so soft that you even cut with knife. So lots of things are there. We can discuss about this. Third thing is what? Third thing, if I say, well, lots of differences between them. Now, third thing is they are good conductors of heat and electricity. heat and electricity. For example, if I say copper, I say silver, so they are good conductors of heat and electricity. Whereas non-metals are bad conductors of heat, bad conductors of heat and electricity. Okay, so a lot of things. So if I take fourth, they have higher melting point and boiling points. Higher melting and boiling points. For example, if I want to take the example of tungsten. If I see its melting point is, I think, 3380 degrees Celsius. In bulb, there's a filament, made up of this metal, tungsten metal. This has a very high melting point. Now, whereas if I talk about non-metals, they are bad conductors. They have bad conductors of heat and electricity, and also they have lower melting and boiling points. They have lower melting and boiling points. Okay. What else we can see? Apart from this, they have high densities and they have low density. More we can see here. What else? They have higher density, low density. Okay, they are malleable. They are malleable and ductile. That is, they can be written into thin sheets or they can be drawn into thin wires. But as compared to non-metals, they are brittle. Brittle means, what do you mean by brittle? Brittle means that is they can be break into pieces. That is, can be broken into pieces. So these are the basic differences in terms of physical properties between metals and non-metals. Apart from this, we have more. We can consider a lot of things like we can say they are lustrous. They are lustrous. That is in terms of shining, like silver. Okay, we have silver, we have gold. Okay, lots of things we have. But they are non-lustrous. If I add to them, they are non-lustrous. They are non-lustrous. But we have exception here, iodine. Okay, so colorful. Well, lustrous is shining is their color. So that is we can add, we can add more physical properties between metals and non-metals. Lustrous, sonorous. If they are, I can say they are sonorous. Okay, what is the meaning of sonorous? That is, they produce sound. Okay, but in case of non-metals, they are non-sonorous. Okay, I can add here non-sonorous. So here we have discussed about 8 physical properties between metals and non-metals. Malleable, high good conductor of heat and electricity, higher melting point, boiling point, high density, malleable, ductile, lustrous, sonorous. So, no, we have lot more to discuss. Okay, so these are the physical properties. I hope you are able to connect with me. So these are the most important physical properties and chemical properties between metals and non-metals. Now, first parameter which we have defined, that is physical properties. Now, the second parameter is chemical properties. Okay. Now next we'll discuss about second one is chemical properties. These are the physical properties. Now we'll discuss chemical properties. A lot more are there in terms of these physical properties. Lot they have given. Okay, more examples we can take, more exceptions are there. So lots of things are there. Okay. Like we can say that metals are of colorful, metals, non-metals are colorless. So lots of things we can discuss in physical properties. Now let's talk about chemical properties. Chemical properties. Now they are chemical properties. Now how we can discuss, like first one. If I say, first let us talk about metals, then we will talk about non-metals. Like, for example, first one is metals. What we can say is about metals react with oxygen. Okay, metals react with oxygen. Okay, so metals react with oxygen to form metal oxide. To form metal oxide. That is metal plus oxygen. What we get? Metal oxide. What we get is metal oxide. Okay. Let us take some examples. Like if I say Cu plus oxygen, guess what? Metal oxide. More examples we can take. Let us take of aluminium. We got what? Aluminium oxide. Okay. I got what? Aluminium oxide. So here we can balance also. If I need to balance, what I got is here I can put 2. So that 6, and here I can put 4. Because remember, we need to write the equation and need to balance it. Okay, so that's how we can do it. Here you can see we have 6 atoms of oxygen here, both sides, and 4 atoms of aluminum. Okay, the most important thing which I am considering in this is that these metal oxides are basic in nature. Metal oxides are basic in nature. But few metal oxides are both. They show both character. That is why they are called amphoteric oxides. Let's take of aluminium oxide. When it reacts with acid, what it will form? It will form acidic salt. That is, if I consider aluminium chloride plus water. Okay, we need to balance it. We can easily balance it. We have like if I put here oxygen, if I put here 2 here, okay, because we have chlorine 3, so we can put here 3. Okay, Now aluminium we have only, also I can put here, yes, 2. But then what we have here, we have 6 atoms of chlorine now and 2 atoms of aluminium. Aluminium is balanced, but in terms of chlorine, here it is 6. I have to put 6 here. Okay. And for the hydrogen here, what can I put is, very easily I can see, right? What we can see here, we have the reactions also. Like for example, if I see, we have lots of things we have there, right? So what we got here is aluminum oxide plus hydrogen chloride. We got 2AlCl3 plus H2. Now here we need to balance. What we can balance how? We have now 6 atoms of hydrogen here, so we can put 3. Okay. Chlorine we have 6, we have 2. Okay. So these are amphoteric oxides because when aluminium oxide reacts with base, like for example if I take NaOH, what will happen? It will show basic salt. This is acidic salt, but here I will get basic salt plus water. So what will your basic salt is? Sodium aluminate. So I will get sodium aluminate. Okay. So that's how what. So we can easily balance everything. I think it's already balanced. We have, if I see, lots of things are there. So we can see that we have lots of chemical reactions. We have here. We can balance, that is sodium aluminate. So I got what is, that is AlO2. That's the formula, sodium aluminate. So I can balance here. So I got this O2 plus water. That is what we can easily balance. Okay. So what is this is given is amphoteric oxides. So finally we got this. So we can say very easily, very easily, that these oxides are amphoteric oxides. Why? Because they react with acid to form acidic salt and base with basic salt. One more example I will take for amphoteric oxides, that is zinc oxide. When it reacts with HCl, what I will get? That is Cl2 plus water. So you can easily balance. When I balance this, what I got, you can put here, it's 2. Now we have oxygen 1. This is acidic salt. You know that. They are amphoteric oxides. Why? Because they show both acidic salts also, and when they get to base, they show basic salt. For example, if I take zinc oxide plus base, this is what? Acid. This is what? Base. So what I will get here? Tell me. We will have, what we will have? NaZnO2. Okay. We'll have, that is sodium zincate. Okay. So we have sodium zincate Na2. Okay. We can write sodium zincate formula is like something. So we'll have this one. Okay. Plus H2. Okay. That is how I got the formula for sodium zinc hydroxide. I can write like this also. Okay. So I got this one. So Na2 here. Okay. Na2 I will got, and here I will got about this. That is ZnOH whole 4. Zn. Okay. ZnO. Sodium zincate. So that is how it reacts with. Now, so these we can consider very easily. You can balance also. That is, they have given zinc oxide. That is, so what we got here is that both are amphoteric oxides. Okay, why amphoteric oxides are what they show both acidic as well as basic in nature. Okay, if they react with acid, they form acidic salt, and if they react with base, they form basic salt. Okay, so these are the amphoteric oxides. One more thing about this metal oxides, they are basic in nature. Okay, one more thing is they do not react with water. That is metal oxides do not react with water. Do not react with water. But few react with water to form alkalis. Few react with water to form alkalis. They are water soluble. For example, if I take sodium oxide plus water, what will they form? Sodium oxide. Sodium hydroxide, that is base, that is called alkali because they are water soluble base. So finally, aqueous. Okay, so they are water soluble, forming aqueous form. That is liquid form. So finally, I got this. Or you can take potassium hydroxide. Okay, so we have lot more example in this. We have lot more examples. We have, so I got what? Potassium hydroxide here, and if I got potassium, so you can write the aqueous. Okay, so that is why they are. So the first property for this metals, that they react with oxygen to form metal oxide. Okay. Now next property we'll see. This is the first chemical property of metals. Okay. That is metal react with oxygen to form metal oxide. If I compare with non-metal, they react with oxygen to form non-metal oxide. Non-metal reacts with oxygen to form non-metal oxide. Okay, so they react with oxygen to form non-metal oxide. For example, if I take carbon plus oxygen gives carbon dioxide, sulfur plus oxygen gives sulfur dioxide. One thing which is important about non-metal oxides, that is they are acidic in nature. They are acidic in nature. Okay. The first important chemical property about non-metal is that they react with oxygen to form non-metal oxide. Okay, but these non-metal oxides are acidic in nature, whereas in metal oxides, when they react with oxygen to form metal oxide, they are basic in nature. The first difference you can easily identify between metals and non-metals in terms of chemical properties. Now, second property, chemical property about metal is they react with water. Okay, now let us see what happens when second property we will discuss about. Now the second property is when what will happen okay, so here I got when metals react with water to form what? Metal reacts with water. Let's see what will happen when metal reacts with water. Okay, first I will write in the word form. Metal reacts with water to form metal oxide plus hydrogen. Okay, or I can say when metal oxide reacts with water, what will happen? They will form metal hydroxide. They will form metal hydroxide. Okay. Now let us take some examples. Okay. Now let us take some examples. Like for example, if I take metal, that is sodium. Okay, if I take this example, when sodium reacts with water, okay, what will happen? Now sodium I will take, or sodium I will take, or potassium I will take. When reacts with water, it's set to cold water. What it forms? Sodium hydroxide plus hydrogen plus heat energy. Okay, I will take an example, that is when sodium reacts with cold water, what will happen? It will form hydroxide plus hydrogen, okay, plus lot of heat energy is released. Why? Because they both react with cold water. Violent reaction, we can say this. Why? Because as soon as hydrogen gas is formed, as soon as it catches fire. So as these are violent reactions. Why? Because they react with cold water so violently, as soon as hydrogen gas is formed, it catches fire and heat energy is released. That is why we say these are exothermic reactions. We can say that when they react with, so we can easily place a potassium, so we can balance also. Okay, like for example, they are given here, we have like H2O, so hydrogen we have 2, and we have 3, oxygen we have, so we can balance also. Okay, for example, now we need to balance this, so we can easily balance potassium. Okay, so I got this. Okay, so this one I got. Okay, so that is what they form. They are violent. Like calcium, it also reacts with water, cold water. But this is not a violent reaction. This is less violent reaction, because whatever the product is, that is calcium hydroxide. But in this, hydrogen does not catch fire. Okay, so this is a less violent reaction. Why this happens? Because in this, what happens? Calcium starts floating, because the hydrogen gas, as soon as formed, what will happen? So whenever the hydrogen gas is formed, you will find its bubbles get stick to the surface on the metal surface. Okay, so this happens. More examples if I take of magnesium, when it reacts with water, but it does not react with cold water. Okay. It reacts with hot water. Okay, so we can say it reacts with hot water to form magnesium hydroxide. Okay, it forms to form magnesium hydroxide. Okay, so that is it happens. Okay, so that is how what they are doing. But few metals are there, like if I ask, say, if aluminium, iron, okay, zinc is also there. I think we have zinc is also there. They do not react with water. They do not react with water. Rather, they react with steam. Okay, if I take iron, okay, for example, now if I am taking the examples of iron, so iron, if I take, it reacts with steam. What will happen? Fe3O4 will happen. Okay, plus side by side they will form, that is hydrogen. In same case for aluminium also. When aluminium reacts with steam, what will happen? When aluminium reacts with steam, so you can easily say it will form aluminium oxide plus hydrogen gas. Okay, so that is what they have. It's there with hot water. Okay, so form magnesium hydroxide. Plus here also we form the same thing like hydrogen gas is there. Okay, here also magnesium. In that case also, I forgot to tell you about that. There is also magnesium starts floating because as soon as the hydrogen gas is formed, its bubble gets stick on the metal surface. Okay, so we know how these react with steel. Okay, iron is there, aluminium is there, so it's given. More thing is about it is what? Like other metals, if I talk about, like silver, gold, lead we have. Okay. They do not react with water. Anyhow. What? Do not react with water at all. Right? Okay. So now we are able to know the second chemical property of metals when they react with water, what will happen. Okay, so that's what they have given. Oh, non-metals. If I talk about non-metals, what happens? Non-metal is what? They do not react with water at all. They do not react with water. Okay, so what is given between this is a difference between second chemical property, that is metals react with water but non-metals do not react with water. Okay, I hope it's clear now. Now we'll move to the next topic, that is the next topic, third chemical property. Okay, now the third chemical property we'll discuss, that third chemical property. Now we'll see what they have given is about what happens when metals react with dilute acids. Okay, third chemical property, that is metals react with dilute acids. We'll take more example. What will happen when metals plus dilute acid, what they will got? They will got what? Acid salt you can say. Acidic salt will get, plus here you will got the what? Hydrogen gas. Okay, so I can write here I got the hydrogen gas. Okay. So lot of things are there in this to discuss about. What they have given is okay. So now next thing is about the metals react with dilute acid. For example, if I take magnesium react with dilute HCl, what will happen? This is my first example. I will form MgCl2 plus hydrogen. Okay, there is 2, so I can add 2 here. More example, I can take iron and react with dilute HCl. What will happen when iron reacts with dilute HCl? So we will get what? Iron 2 chloride plus hydrogen gas. Okay, so then balance it also like this. More examples, we have magnesium, we have iron, we can take zinc also. More examples to satisfy this, zinc with dilute HCl. What will happen? ZnCl2 plus H2 gas. Okay, so what I got is about this gas. Okay, one more example. If I take aluminium and react with dilute HCl. We all know about the difference between dilute acid and concentrated acid. Concentrated is more dangerous than dilute because they have 90% of acid. As compared to dilute, they have 90% of water. So you can see. Now, when it's reacted, what will happen? AlCl3 plus hydrogen gas. Okay, so what we can take? I can take here 3, 6, and I can write here. Now it's balanced. Okay, 2 aluminium atoms are there. 2. Now hydrogen we have 6. Fluorine we have 6. Okay, so that is how they react with dilute HCl. If I take more example of dilute acid like HNO3, because mostly if I take example of magnesium, I can take for HNO3. What will happen? MgNO3 whole twice plus hydrogen gas. Manganese I can take example for HNO3 dilute. Here also MnNO3 whole twice also, whole twice plus hydrogen gas. Okay, then we can balance also. Likewise, if we need to balance, we can balance also. Like the hydrogen is 2 there, so we can write 2 here. Same here. So we need to balance also. So this is the third chemical property, that is metals react with dilute acid. Let us talk about non-metals. Non-metals do not react with acid at all. They do not react with acids. Dilute acids, certainly the reaction doesn't happen. Okay. Now let us move to the fourth reaction. Fourth chemical property. We'll discuss about that is fourth chemical property now. I hope it's clear now. So lots of things are there. You can easily identify our metals and non-metals. Okay, so it's easy. So let's move now. 3 we have done. Now fourth one. What it is? Metals react with other metal salt solution. For example, if I take like first I write metal A plus metal B salt solution. Okay, metal B salt solution. What I got here is metal B salt solution. I got metal A salt solution plus metal A plus what? Metal. For example, we have discussed also when iron reacts with copper sulfate solution. When iron nails are dipped in the copper sulfate solution, when it is of blue color, what will happen? It will form like this. That is, iron will displace copper. Okay, so what will happen? The solution of ferrous sulfate here, it will loses its color. Okay, so that is what you can do. Okay, so these are the chemical properties which easily distinguish between the metals and non-metals. Okay, one more thing is non-metal reacts with bases. Okay, but they form the product which we get will be very complex in nature. I'll talk about it. Let us see about non-metals. Non-metal, what they have given is about non-metal is, that is, for example, if I take base plus chlorine, what will happen? This is non-metal, this is base. What will happen? Now it will form NaCl plus what will form? It will form water. So plus they will form sodium chloride. This is very complex in nature. So that is how the non-metals chemical properties as follows. One more thing is we can talk about, now we have seen here that they are different in nature. You know, they have different chemical properties. They react to different type of compounds are like this. So now when we say reaction of metal and non-metal, what will happen? Reaction of metal and non-metal. So we'll see here, so very easy form, metal and non-metal is like, for example, if I take sodium plus chlorine, okay. Now when metals react with non-metals, okay, when they react with non-metals, what will happen now? Like, for example, if I take the example of sodium plus chlorine, what will happen? There will be sodium chloride. Here, sodium is metal and chlorine is non-metal. Okay, so like you can take here example here, sodium, what will happen? Sodium will lose electron. Okay, sodium will lose electron. Okay, whereas chlorine will gain. Okay, chlorine will gain electron here. Okay, so that is to, you know, in both cases we can see here electrons are transferred. Okay, like for example we have 1 plus react with chlorine and like this. So what will happen? It will be transferred to this to form NaC. Okay. One more example we can take. Is of, that is magnesium 2 plus. So what will happen? It will lose electron. Okay. It will lose electron and chlorine will gain. Okay. Chlorine will gain electron. Okay. So that is what they have given in both the cases, like what we can take. So it is what happens. Now that is what they form. Now this is a metal and non-metal. So finally when Mg2 plus chlorine Cl2, what will happen? It will form like this. If I say not like this, it will form Mg2 plus. So I have chlorine. If I show by electron dot structure, so what will happen? Here we have 2 electrons, so it will transfer to here. So finally it will form MgCl. Okay, I got 2. That is how when metal and non-metal reacts. Okay, so this is how we can show easily. That is, Mg is a metal but chlorine is a non-metal, so they are formed like this. Okay, so that is how we can write like this, 2 plus. Okay, so here magnesium loses electron and chlorine gains electron. So that is how metals reacts with non-metals. So I hope it is clear now that how we can distinguish between metals and non-metals in terms of physical properties and chemical properties. So if you have any doubt, you can comment, you can like and share my channel. Thank you for today.